Alright everyone, welcome back to another episode of Garage Science. So I'm gonna be making this device here today. So what you're looking at here is the final assembly. This object underneath is the CNC table for the PCNC 440 by Tormach. That's the CNC mill that I have in the shop. And so what we're going to do is make this tile engraving fixture. Because basically when you engrave tile, you generate ceramic dust, and if you let that mix in with the rest of your machine coolant, and if it gets blown all over the inside of your mill, then chances are it's going to work its way into the ways and the other linear components, and then it's going to wear everything down. So what this fixture is going to allow you to do is fill up the tank with coolant and circulate that coolant within this tank, and so that way you can still keep the top of the tile covered in coolant to wash away the dust as it's generated, and provide a little lubricant for the cutting tool, and also maintain all of the bits of ceramic in the tank versus mixing with everything else. Alright, so what it's going to be is this is just a mock tile, so we'll go ahead and hide this guy real quick. So what it is a series of standoffs and then support rails. And then what you also don't see modeled here is there's going to be rubber strips on the top here, so there's kind of a soft place for the tile to sit, so there's no risk of cracking or chipping the tile while you're cutting it. Should also kind of reduce the noise as well. These square tubing covers here basically are going to go around the mounting bolts for the fixture, so you can actually bolt it to the CNC table out in the corners. And so really you should be able to put everywhere from a smaller maybe 2x2 inch tile on here all the way up to a 12x12 inch tile, and then what you see here, I can bring my mock tile back. So this square here, right, this is basically the cutting area of the XY work area of the PCNC 440 CNC mill. And so what this kind of visualization lets you see is that you can still do a 12x12 tile. You would just have to do one half, flip it, and then do the other half. And then if you really wanted corner to corner, you'd probably have to do it in quadrants, because the X travel isn't quite 12 inches. So yeah, we'll see how it goes. I kind of just want to do this to play around with it. I'm mostly looking for a project to use as an excuse to practice aluminum welding, so I thought this was a pretty good opportunity to try that. So we'll see how it goes. All right, so stick around. We'll be working everything based off of this CAD model here. Alright, so we're going to go ahead and mill this component for the tile engraving fixture. You'll notice it's actually pretty big compared to the table. It's bigger than the work area of the mill. So basically this is going to be a 2-op part, even though it's pretty much just a simple array of holes. Not milling the top or the sides for this, and just because don't really need to, really just need to get the equally spaced holes. And then these are tapped. I already tapped them manually. There's some modifications you have to do to the PCNC 440 to get it to do tapping, and it's not something officially approved by Tormach, so I'm doing manual taps on this. But yeah, let's go ahead and get started. So these are some homemade parallel plates out of some simple 1/8 inch thick carbon steel. So nothing super fancy, but made these up last week. Alright, so we're going to probe. This is a homemade mill probe. It's basically precision ground 3/8 inch aluminum round stock. with a wire that's secured to the top of it. It's got paint on the top of the shank that electrically isolates it from the rest of the column, and so we'll connect it with a multimeter between this and the vise so we can find zero. So once the probe makes contact with the vise, the multimeter will ring out and we'll know that we have contact. Okay, so that's 0 on the X. Now we'll do Y. All right, now we're gonna do the Z0 on the actual stock. Right now we do have to add the offsets and path pilot for the radius of the probe. Again, you can see, I'll put a link in the video description on how to basically make a probe like this. So next thing we need to do is we got to support this end of the stock. So it's going to take a second to set that up. Okay, so got a kind of a finagled setup here with the fixture clamps. See if I can get a little better shot with the GoPro. All right, so with the fixture clamps, that's a little better. Basically, I'm providing some support on the bottom and the top, so that way the up and down pressure from the drilling operations doesn't cause any flex, because we're basically going to be working all the way out to about right here, which is around about the middle of the stock, and then we'll have to flip it and do the other half. And off we go. Alright, so that's the first half. We're going to flip it and do the second half so that we get holes all the way across. Just like that, we're ready to go. So this is a symmetrical part, so we're going to use the exact same program for the second half as we did the first half. There we go. So just got a bunch of tapping ahead of me. Alright, so we're going to go ahead and tap this with a 5/16 by 18 thread size tap. And just a quick note, so what I'm actually kind of figured out recently to do in terms of when I do tapping is what I've done is I've mixed the same quality chem cutting fluid that I use in the mill. Basically mix up a higher concentration solution for that, and you can do that for specifically tapping and threading. And what that'll allow me to do is have a cutting fluid for manual tap. So helps it go a little faster, helps keep the tap cool, and prevents it from binding and potentially breaking inside the hole. But there are 5 of these pieces. Each one has, I think, 20 holes. This is going to take a while. So 100 holes to tap. So, and then you can also use a little brush to work some cutting fluid into the hole as you tap as well. So I got this tap from McMaster. That's where I get most of my taps from. They're all pretty good quality. Maybe not the cheapest place in town, but I've never had an issue with their tools like this. There we go. So I did 20 already on the first one. That makes 21. Only 79 to go. So I was as riveting as I'm sure it is to watch me tap holes, I'm going to go ahead and skip this part for your sake. Well, so all 5 of them are done. These are the kind of biggest, really actually kind of the most complicated components for this fixture. And so it just took an extra operation because these are larger than the work area of the Tormach PCNC 440 that I have. But it's basically 20 holes across, tapped with a 5/16 by 18 thread. And so what that does, that matches up the same threads with the work holding kit basically that I have. That it's also the same threads that are for mounting fixtures to the table. So everything should be basically cross compatible, which is kind of the point. But this will allow you, it's wide enough to sit a 12 by 12 tile on it and be able to clamp it down from the edges pretty comfortably. So that's what we'll work with, and I think it'll work just fine. One thing that we'll do by the end is we've got some rubber from McMaster car, and what we're going to do, they're 1-inch thick strips, and so what we'll do, they're adhesive backed, and we'll stick those to the top of here, and we'll do the cutouts obviously for the holes, and then as the tile sits on it, it'll have, you know, kind of a semi-hard rubbery surface to sit on, so minor vibrations and everything should get kind of dampened out. So that will be beneficial. Probably help with the noise, but also reduce the risk of cracking or damaging the tile while you're milling it. So yeah, we'll see how it goes. Off to the next piece. All right, so got basically the longer kind of rail support piece that'll go at the top. I guess I should say the shorter rail piece. So that'll go at the top of the fixture, kind of butt up against the wall, and then the actual fixture rail will get welded to the support block. So I'm doing the supports in smaller blocks, so that way the coolant underneath can kind of circulate and flow in between the rail pieces. So there's kind of an easy direction of flow there. So basically rough cut them on the miter saw with a metal cutting blade, and then taking them to the mill and facing off the ends to actually trim them to the correct size. So they're slightly oversized. You can kind of see there a little bit. Pretty simple. Just doing it manually, using typing in some manual G code in PathPilot to mill that. Pretty convenient. And yeah, I got to do 9 more of these, and then for the other ones I got to do 15. So it's gonna take a second. Well, I've got actually all the pieces cut now, with the exception of the square tubing that we're going to use for the bolts that are going to secure this to the CNC table. But basically I've got the long walls cut and the short walls cut. Also got the support blocks, the long support blocks and the short support blocks cut. So there's 10 of the short ones, 15 of the long ones, and then got all 5 of the rails cut and the actual base plate cut as well. So this is 1/8 inch aluminum, and then so are the walls. The walls are actually cut from the same sheet the base plate was ordered from, and so the walls are 2 1/4 inch high. Basically I sized that to be tall enough to where once the rails are in place and welded on top of each other, there'll be a big enough gap between the what would be the top of the tile to the edge of the wall, so that way the tool holders won't crash into it during any milling. So basically the bit should be able to get all the way up to the edge of the fixture without the tool holder crashing. So the next step is to drill the holes for the base plate, and so that'll be for the 5/16 inch bolts to mount it to the CNC table, and then also need to cut the square tubing that's basically going to sit over the bolts, so that way that keeps water from seeping through the bolt holes. And I didn't want to do like a rubber grommet or anything like that for the bolts, because then basically I would have to completely empty the tank of coolant every time I took it on or off the CNC table, and so I just wanted the ability to remove it with maybe all the coolant, or maybe just at least a little bit of the coolant still in the tank. And so by basically sealing out the bolt holes with the square tubing, I'll weld around the base of it to keep it watertight, and so then you'll actually be able to get a socket down the center to take the bolt on and off. So that's the goal with that. But yeah, everything's prepped and ready to go. Just about ready to start welding. Alright, so I've got the risers welded on here. I gotta clean them up a little bit still. The welds don't look super great, but you know, first time doing aluminum welding, so not too bad, I guess. Everything's still properly bonded. One thing I did realize as I fitted this to the table was that I actually mismarked these holes, so I had to widen them with a Dremel tool. But as I was welding, between the heat of welding and clamping it to my welding table, noticed that the plate actually deformed just a little bit, so it's not perfectly flat anymore. Kind of hoping that doesn't mess me up in the future, but also realizing as I put it on the table that any slop in these holes is going to cause this to kind of misalign out of parallel. So what I want to do is align it and use these guys as like a washer for the bolt. And so alright, so here you go. So these are the bolts that I have to hold down my other fixtures onto the onto the CNC table. So by using this guy, it'll fatten it up a little bit. So I guess I'll be less likely to deform the plate as I tighten it down. But also I machined it so that way it fits perfectly inside the tubing, right? And the tubing is basically there just to provide a water barrier, so that way the coolant that will eventually fill the tray won't go down through the sides of the bolt and drain out. So so I'll get that welded on here next, but I want to get the position for the tube marked with the table in place, and so so that's why I wanted to get those these washers made up, because there's no slop, because I was able to machine out with an end mill the center of the hole for the bolt, so it's very snug in there. It's not as good as reaming, but it's very, very snug. And then the washer itself fits snugly in the tubing, so as long as the tubing gets welded in the right spot, the bolt should be like perfectly lined up for a parallel and properly located fixture. So that's kind of my plan for that. Alright, so before I go through starting to weld this up, I kind of want to talk about this nifty little setup here to try and clamp these the square tubing in place. I actually milled away the side of one of the tubes, because basically it's going to sit right up against the side wall here, and so yeah, so anyways, so it's going to go there. But basically what I had done is, because there's some play in the holes, they're a little oversized, and basically what I did was I set the fixture on the mill table, bolted it down, had it squared up, lined up, and then tightened all the screws down. Because these the square washers fit very snugly inside the square tubing, then you can set the square tubing over the top of it, and it pretty much places the square tubing where it needs to be welded. And so I marked on the table right where that needed to be, and now after the fact, I basically put these standoff bolts through here. These are actually part of a clamping set I got for the mill, but it's pretty handy to just send it all the way through the washer and clamp on the top and bottom. There's a nut on the bottom as well, and then it continues all the way up through the tube, and then there's a little flat plate on the top to just clamp everything down sandwich style to hold it in place. So we'll do that for each of the holes. That should keep everything pretty much like exactly where it needs to be, and there shouldn't be any issues with things getting shifted or being slightly out of alignment. So we'll see how that goes though. All right, so working on getting the walls welded up. So the post covers for the mounting bolts, those are welded in. Those weren't too troubling. It's mostly just getting them aligned properly, and then also got the flat bars that the tiles will actually sit on welded on as well. The biggest problem with these, like I could do the two on either side, the two closest to the outside, pretty easily with the clamps that I had. The center piece was actually a little harder because I didn't have enough. I didn't have any clamps with enough throat depth to reach to clamp that guy down, so I actually ended up using a ratchet strap and a piece of square tubing sticking up off the top of it to basically push down from the top down on it. So I had to get a little ingenuitive with that, but basically for these welds, I'm not very good at aluminum welding, as you can really tell. Everything that I did reading online, just you take your risks with that. A lot of places say that the MIG welding aluminum is easier, just more expensive, and so I kind of didn't buy a TIG welder, thinking that I would kind of invest in and get something that would be easier to pick up. But anyways, the Lincoln Electric 180 weld pack welder that I have with the MIG gun is, I'm not quite sure that's quite the quality you need to do aluminum welding. So by all means, let me know in the comments what a good MIG welder is for aluminum. I got the feeling that having the finer adjustments on the voltage setting, and then also there's a lot of welders that have a pulse setting for DC MIG welding, and so I kind of tend to think that that's probably something that I'm missing. But I've tried every wire speed, every voltage setting on the Lincoln electric welder that I have. I've tried different stick out lengths, different travel speeds, different gas flow rates. Like, I feel like I've tried pretty much every combination, and I mean, the welds, they like hold. They're disgusting looking, and if there's one thing that I have yet to see, like across the board with any of this, is wetting around the edges of the weld. Every single weld, it either over penetrates like you see here, or it's like a glob on the edge, and so none of it is that nice smooth kind of transition wetted weld tip. And I don't know how to get that, and I'm tending to think that you can't get that with a welder that's kind of, I guess, more on the low end like this. So let me know in the comments what you think. There's got to be a welder somewhere out there that's watching this that can provide some insight, and let me know, because I kind of tend to think I'll be in the market for a different welder relatively soon. So anyways, but nevertheless, it bonds the metal, so it's not going to win any fashion shows, but it'll work. Alright, so I'm done with the assembly, at least with the welding portion. It looks hideous, so be sure to leave me all your love in the comments. So one thing that I did kind of notice that I could do was I ended up dialing down the wire feed settings a little bit, and just kind of taking my time a little bit more to try and give the arc a chance to actually melt the base metal. And so some of the inside corner beads that I put down is just kind of practice, since I primarily welded the outside edge to get the joint. But I took the opportunity to kind of practice on the inside corner, and so I actually got like kind of decent looking beads. They're not real great. I'll try and zoom in here. You know, still not great, but way better than, say, that, I would say. Anyways, it's got a little ways to go in my skills set, but this is by far the not by far, it's the first time that I've welded aluminum, so, you know, yeah, not too shabby, I don't think. I wanted to weld the bases of the columns for the bolts, and they still leak just a teensy bit at the bottom, so not watertight. So what I'll probably do is the square washers I made up, I'll put some silicone sealant at the bottom of those, and when I shove them down there the first time, I'll just screw them in with some silicone in there, and that'll seal up any remaining little pinhole leaks. Other than that, we're going to put some rubber on the tops of these guys, so that way it kind of dampens the vibrations on the ceramic tiles a little bit. That should kind of help with the noise. It should also, I think, prevent the chances of chipping and that kind of stuff. And ultimately, what I'll probably end up doing for hold downs is I'll probably end up 3D printing some clamps, just so that way there's again some vibration absorption in the clamps as well. So I don't really want to avoid metal on tile. That sounds like a bad combination. So anyways, just about there. Got about 95% of the work done, so more to come. Alright, so the fixture is complete, ready to be able to put this in the mill, draw something up in cam and try it out. So essentially how this will work is I sized it to accommodate a 12 by 12 tile, so it'll be able to sit in there like that. The actual milling area is only about half of this, so if I want to do the entire area of a tile, I'll have to do one half and then flip it around and do the other half. But the rubber will help dampen the vibrations from milling on the ceramic tiles, and so that'll eliminate some of the potentials for cracking or, you know, excessive vibrations in the tile that might affect the quality. And then all these are tapped with 5/16 by 24 taps to accommodate the threads for the posts and clamps that I have for the Tormach. And so basically I'll be able to take like a scrap piece of rubber like so and essentially clamp it into place like that. So you know, that'll allow it to be held securely, obviously, and then I'll actually end up having to use one of the larger ones to sit down here, so it'll actually end up going a little more like this. But it gives you some flexibility, and then also it's because it's big enough to accommodate you know, a full-size tile. Then some of the smaller, more awkward-looking tiles are still able to be accommodated. So because the rails are close enough together, even a smaller 2-inch tile will still fit between the support rails, and you know, larger, oddly shaped tiles should fit in there as well. So I'm looking forward to kind of experiment with this and see how well it goes. So then the other thing that I'll do is, so this what I got here is a simple submersible pump, and so what this will let me do is create a flow of coolant slash lubricant over the surface of the tile as it's being cut. So I'll keep this guy probably off here in the corner. It's got suction cup feet. Because of the way the coolant pump is set up on the Tormach, I can just unplug the flood coolant pump and plug in this guy, and then when I turn on coolant in cam for you know, particular milling job, it'll actually turn on this pump rather than the flood coolant pump, and it'll work all the same. So looking forward to having that feature available. But this is just a simple submersible pump. I think I bought it originally for like $9 or something like that. I'll link to it. I got off of Amazon, so there will be a link in the description. Well, yeah, almost there. Almost there. Alright, so normally for the coolant power, this goes down into the cabinet for the flood coolant pump. We're going to go ahead and unplug that, and then what we're going to do is plug in the submersible pump in the fixture tray, and that will go in like that. So when the G-code gives the command for starting flood coolant, it'll power the small submersible pump in the fixture. Alright, so I have the small submersible pump here. I'm going to 3D print some stuff to actually kind of hold this in place a little better than this, but I got a simple clamp and a zip tie for the hose, discharge hose coming out here, and then one of the toe clamps I got pinching the end, so it kind of flattens it a little bit, so it creates kind of a fan spray here along towards the tip of the mill. So I'll go ahead and turn it on in Path Pilot, and there you go. So that will create kind of a fanned out flow of coolant across the top of the tile, so that way as the mill runs, it's constantly washing away the cut ceramic away from the bit. So that should work pretty well, I think, and then all the ceramic will collect in the tray, so it doesn't mix in with the rest of the machine and potentially ruin you know, some of the high tolerance fit components, the ways and lead screws and everything else. So this should allow us to engrave ceramic long term, many times without risk of damaging the mill. So we'll fire it up and see what happens. Well, there you go. So just a simple smiley face sketch that I drew up in SolidWorks. Saved it as a DXF and ran it in the conversational milling in PathPilot, and took about 5 minutes to set that up, and you know, it turned out pretty nice. There's a little pocket there in the lip where the depth of the V-tip on the blade didn't quite catch it all. But you know, it got the different size eyeballs, got kind of the triangle-shaped nose, and it's a good overall shape. No chipping of the ceramic anywhere. I can probably mess with the feed rates and probably bring those up a little bit. And all the coolant stayed within the tank, so absolutely no issues whatsoever overall. So this is going to be pretty nice. I will have to work with the rapid feed rates a little bit, because as you could kind of tell in the video as it was milling, that as the table shifted right in between different routines, it sloshes the water a little bit. So the way I designed the standoffs and for the support rails kind of helps minimize some of the sloshing, but especially over here on the left side where there's kind of a bulk tank type area, you don't want to slosh any of that water out of the tank, so I'll have to reduce the rapid feed rates a little bit when doing the engraving. But overall, very, very pleased, very effective. Can't wait to play around with this. Alright, so make sure you leave your comments in the comment section. Like the video, subscribe, and check out some of my other videos. Really enjoyed making this project. It took a while, primarily because it took so long to kind of get my feet wet aluminum welding. So by all means, leave your criticisms in the comments and let me know what you think. Alright, thanks for watching, everyone. Until next time.